Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, I have this HP DPS-240 FB-1A1 A revision, 240 watt, 100 to 240 volt input. It is a working power supply, functional power supply. We will open it and we will study it, how this circuit is working and how we can troubleshoot it. We will make a reference, either this power supply is a functional. First of all, open these screws, pull it to back side. This cover is opened. We removed 3 screws, 1, 2, 3. Now we have to open this screw here, and the second screw is here, the third screw is here. We have 3 screws for this cover, 1, 2 and 3. Now pull it here, now pull it this side. First pull in this side, then slide it away. Now the power supply is on. Set multimeter to volt. Connect only to chassis, or we can connect to black lead, and we have to check the voltage on purple wire, that is here. This purple color wire, we have to check voltage here. It is 5.148 volt. It is a good working condition. Now we have to check voltage on this green wire. This one, it is 1, 2, 3, number 4, 5 number wire. It is 4.6 volts. All pins are low. Just only number 1 pin, that is purple wire, that is 5.1 volt, and we have a resistor voltage that are 4.6 volts. Now we will connect a jumper between this green and black wire that is next to green wire. So we will connect jumper. Now it is power on, and we can see the lamp is glowing very dim. Now I connected the jumper. When I remove the jumper, this power supply will turn off. We will turn it on again. 1, 2, 3, 4, 5. Now it is on. We can check voltage on the yellow wire. It is 12 volt. The red wire 5.1 volt. Orange wire 3.45. Because this power supply, it is out from the board. When it will connect it to the motherboard, it will regulate 3.3 volt. Why? Because it have a sense line from the motherboard. This 3.3 volt will go to motherboard, and it will sense the return voltage, that is called regulation. So it have 5.1 volt. So this power supply, basically it have DNA002 IC and LM339. Here it have TL494. It have active PFC circuit. So let's check it. Now we will open it. Remove this connector. Then remove this screw. The third screw, that is hidden in this corner. It is visible from here, so let's open it. So it is removed now. Then we have this power connector. We have these 2 screws here. Open it, and in the rear side it have a clamp. Now remove it, remove this earthing. Now carefully slide it out. Now our power supply is out and we have fan connections here. Now we have the fan here. We can remove the fan as well. So we will test it. Now this frame is empty. Now if we see the power supply configuration, input terminal, the grounding strip, fuse, and after fuse we have two filters, first stage, second stage, and then we have here bridge rectifier. After bridge rectifier we have here PFC choke, and then we have just only single one capacitor here under this heatsink. Never touch to any component or hot area or any component here, especially this capacitor, because it is 450 volt capacitor. Now we will connect some two or three screws so that the airflow must be present. Now it's good. Now I will connect power. As I told, it is a PFC power supply. Set multimeter to DC voltage. Check at this capacitor. It is 328 volts. And when I will connect the power on command, 1, 2, 3, 4, 5 and 6. Now we have to check the multimeter response. 1, 2, 3, 4, 5 and 6. So it is 367 volts. When I remove the jumper, the power supply returns back to 328 volts at the capacitor. But when I will power on, check again. Here we have just only one capacitor. This power supply does not have two capacitors, because in normal power supplies, in ATX power supplies, we have two capacitors and each capacitor have 160 volt, but this power supply, it have just only one capacitor that is being charged at 367 volt. When I will power off, in that case it will return back to 329 volts. It is the condition when I am applying here line voltage line voltage are 231 volts. In this condition I am taking 328 volt DC at the capacitor. When I will give power on command, first of all this power supply will maintain its voltage on this capacitor at 367 volts. Now I will change the input voltage. Now I will change the input voltage to 115 volts. Now we will see the response the voltage level at this capacitor. It is 162 volts. And now I will check how much the voltage are here, and when I will turn on the power supply, what will the voltage level. We can see this time I am giving through the lamp and I applied 110 volts. So in this condition, this power supply is trying to turn on the PFC circuit, but PFC circuit is not turning on. So that reason the power supply is not turning on. What to do? I have to remove this cable and I have to give a direct voltage 115 volt to the input socket. Now I will give 115 volts and I will remove this power. This time I am turning on the power supply directly, because when we apply through lamp and when power supply have to turn on, in that condition it will drop the voltage. So now I applied 110 volts. Now the input voltage are 115 volts, and if we see the capacitor, if we see voltage at this capacitor, it is maintained at 367 volts, and if I remove the jumper, the power supply will drop to 160 volts because I am applying 115 volts. It is called Active PFC Circuit. In this PFC circuit, we have a Pfc Controller Ic. That PFC Controller Ic will switch and it will make a resonant circuit with this coil, and a rectifier will pump this voltage to the capacitor. Now we have 164 volts. That are the regular output of the 115 volt after rectification. And if I will turn on again, it again reached up to 367 volts. Why? It is boosting the voltage. Now we will discuss. I am applying 115 volts. What is the reason it is boosting up the voltage at this capacitor for 365 volt, 367 volt? To turn on the second section. At this voltage level, we have a standby section that will give 5 volts. But to turn on the second power supply, the secondary main power supply, it will use Pfc circuit to boost the voltage. Why? When we discuss a power supply, it have a input filter, then we have a DC rail, it is a bridge rectifier and some capacitors. That's to rectify the voltage. Here we have AC voltage and here we have positive and negative voltage. In normal power supply, when we discuss a switch mode power supply, a normal power supply, it have a switching MOSFET or transistor or whatsoever. It will give a drive signal to this transistor. Here it is giving 320 volt DC positive. So it will all power supplies will control switching on vs switching off to adjust the voltage. If it have 320 volt, it will use its minimum turn on time so that the minimum current will flow in the primary and we will take voltage in the output. Now this IC, this controller here, it will adjust its duty cycle in two conditions. First conditions, if the line voltage drop, for example, it will drop to 200 volt. In this condition, this IC will increase its turn on time vs turn off time, so that now the voltage are dropped, so it need to build a magnetic field. In that case, it will increase the current, it will increase the switching on time so that the more current will flow and more strong magnetic field will build up, so that it will cut to the secondary and we will take voltage and the output. It is the first condition, if the line voltage are dropped. Second condition, voltage out with no load, voltage out with full load. It have two conditions. This condition, in this condition, it will use this switching on time. It will use minimum time to switch so that magnetic field will build and it will pass the voltage and there is no consumption in the secondary side, so the level will maintained and this IC will keep switching for a little time. In a complete cycle, if we have from here to here, we have one cycle, so it will use only this time to turn on, other time it will remain off. So it will turn on for this time and other time it will utilize to turn off. So this cycle will remain silent in this period. From here to here, it have one cycle. We can say if this IC is switching at 100 kilohertz, that means this transistor will switch for 100,000 times in 1 second. 100,000 times in 1 second. It will generate 100,000 cycles from here to here in 1 second. So part of this cycle, it will utilize this time for turn on, other time will turn off. It is called one cycle. So in one cycle it will turn on for a little time so that the low current will flow. In that case, low magnetic field will build and it will generate a voltage to keep maintaining in the output level. When we connect load, in that case a feedback circuit will inform this circuit that there is a voltage drop. When the voltage drop, for example it was 12 volt, now the voltage started to decrease, this IC will increase its switching time. As soon as it will receive a feedback that there is a voltage drop, this network will give feedback and it will increase its switching time, so that when switching time will increase, the dropped voltage will fulfilled by the enhancement in the magnetic field. It is a normal power supply. We discussed two conditions. First condition, the second condition. But if we discuss this power supply, it have a separate network here between this, that is additional, or we can draw in the next page. That is good. We have here EMI RFI filter. Then we have bridge rectifier and we have DC capacitor. And from this point we have another network that is called Pfc circuit. This circuit will give also positive voltage to this line when it is a condition. What is the condition? Because it is a power consuming component, it is a resonant circuit. In normal condition it will remain silent. Now from this voltage, from this section, we have SB section, standby section. It will take voltage and it will give 5 volt output, that are called 5 volt SB, and this 5 volt SB will apply to secondary section VCC. All components in the secondary section, it will apply biasing voltage. And here we have PS on command. When we want to turn on this section, the secondary output, this section will receive a command, and first it will give a command PFC on command. When the PFC will turn on, in that condition it will pump voltage. First I applied 115 volt. I was receiving 160 volts. But when we will receive this PS on command, this PFC circuit will boost these voltage. It is taking from the DC capacitor 160 volt from DC line, and now it will pump and it will make 365 volt DC. Now the system changed. PFC will turn on, it will switch, it will maintain these voltage. When these voltage will maintained at this level, in that condition it will give a feedback here. It will sense DC rail. How much voltage are on DC rail? If this voltage are true, 365 volt, then it will turn on secondary power supply and it will switch these DC voltage, and we will take 12 volt, 5 volt, 3.3 volt, whatsoever. And these voltage, now these voltage from this point to this point, here we have ATX supervisor. This circuit will check for over voltage, under voltage, over current, over temperature. It will monitor all the conditions. If any one condition will exceed from its specified limits, which is in the datasheet of this IC, in that condition it will disable this PS on command. So it is working phenomenon. Now what is the reason for PFC circuit? Now as we discussed here, this IC have to maintain two conditions in normal power supply, in normal ATX power supplies. If the voltage will drop, in that condition it will increase the duty cycle, and if the voltage will drop, it will increase the duty cycle. If the both conditions meet, input voltage are dropped and there is a full load, in that condition the efficiency of this power supply will drop. But in this condition, this power supply have only one duty, that is to maintain the voltage. It have no responsibility to maintain the voltage, because for maintaining the voltage we have a PFC circuit. How the PFC circuit works? AC line, we have bridge rectifier, positive, negative. It is charging this line. Now we have one coil here, inductor, then we have MOSFET here, and here it have a PFC drive, and in this point we have a rectifier, we have a diode, and it will connected here in the capacitor. So this capacitor have two ways for charging. The first way, that is the rectifier line. Here we have AC voltage. AC voltage are applied to bridge rectifier and it will rectify, it will give directly to the capacitor. The second side, this inductor, it is connected to ground through a MOSFET. Here we have MOSFET. So this MOSFET will remain silent. If it is silent, then there is no consumption of the current. But when it will receive a PFC on command, here, this IC PFC controller, not drive, we can say PFC controller. So it will start switching. PFC controller, first of all, it will take a DC voltage. What are the voltage here? It will monitor the voltage, and based on this voltage information, how much voltage, if it have 330 volt for example, and it have to boost up to 365 volt. Here it have another diode here to protect the reverse. So now in this condition it have, we can say 330 volt, and it need 360 volt. So in that time it have a very low margin. 330 volt available, we need 365 volt. So for 35 volt, maybe it will start switching for a short time. It will drive this MOSFET like this. But if the voltage are dropped about 165 volt and it have to 365 volt, in that condition it have to increase 200 volt more. So in that condition it will turn on for the long time. So the turn on time of this MOSFET will increase. Now what will happen? It is working concept. When it will switch, it will cause to flow current a surge in this inductor. When this inductor will store energy, at that time off time will reach. This MOSFET will turn off. Now this expanded magnetic field will collapse. When it will collapse, before this end was positive, but when the magnetic field will collapse and there is no return line, because here we have just only this MOSFET, so it have no return line. So this end was, before this end was positive and this end was negative because it was close to ground line, but now due to collapsing magnetic field the voltage will reverse. So this end will become positive, this end will become negative. Here we have 165 volt. 165 volt, and this stored energy, when it will make voltage, we can say it have to produce 200 volt more. So now we have two sources in series. This end is positive. Now the coil, this end is negative and second end is positive. So we have two batteries in series. Positive, negative, positive, negative. What are the two batteries? 165 volt source and the second, this inductor, first and second. Now we have 200 volt. So two batteries in series through this diode, it will reach 365 volt at capacitor. So one battery, one path is here, it is charging, but now in the same path, because this diode is protecting to return. So now it will increase the voltage from this line. So this capacitor will maintain at 365 volts. Now the voltage are maintained. We have ATX supervisor. We have PWM controller. It will control, and we have LM339. These complete network, these will monitor the voltage, and these will keep switching to produce output. Let's check now. Now I hooked up oscilloscope at this PFC drive. I hooked up to measure this signal from this Pfc drive circuit, these two lines, these are reaching from here. And now I will check the voltage and then we will check the PFC drive. This time I have AC voltage 233 volts, and in the DC capacitor I have 329 volts. Now I will turn on the power supply and then we can check. Now it is turned on. So the drive signal it is switching at 69 kilohertz, we can say 70 kilohertz, and the switch on time, that is very low. And this time, as it is inverted signal for the MOSFET, so it is turning on for very narrow time. Now I will change the voltage. Now I switched the system to 115. I have 115 volts. Now the voltage at DC capacitor in this condition are 163. Now we will check the response. This time PFC circuit is off. It is not working because our drive signal that is connected here, it is off now. Now I will turn on the power supply and we will check. Now it is switching at the same frequency, but the duty cycle now increased. You can see its working time, duty cycle is changed now. Now the duty cycle is approximately 60%. So 68%, 60% duty cycle is used to turn on the PFC circuit to boost the voltage. It is in condition in 110 volts. In 220 volts, because it is inverted signal, 91%, so it is using only 9% to turn on MOSFET, so it will switch for narrow time because this signal is inverted signal. Now we can see this original signal. Now it is in original shape, so it is just only 10%. Up to 10% it is switching to turn on the MOSFET gate, which I discussed here. So it will use only 10%. So it is boosting the voltage. It is our first point, that in PFC power supplies, any power supply, either it is in TV circuit, either it is in any computer power supply or in air conditioner boards, anywhere that have PFC circuit, active PFC circuit, power factor control, power factor correction, the PFC circuit must turn on to turn on the main power supply. The standby power supply will work directly. Now we will check the standby power section. How this circuit is working. In this power supply, we have this rectifier that is reverse protection from the PFC circuit. Our rectified voltage are passing to the capacitor from this point directly, and this diode will feed this voltage to this inductor, and here we have this MOSFET and diode, and then this voltage will reach here at the capacitor to charge it. Now we have this PFC control circuit. We have this standalone circuit here. It have a Pfc Controller Ic. It will check the voltage what are on the DC rail. So this board, it will measure the DC voltage, how much voltage are there on DC rail, and then it will decide to make switching on these two lines. One is low line, the second is drive for the gate. And here we have resistor and diode SMD components to drive this gate of MOSFET, and this MOSFET will switch. This MOSFET, so source is connected here, drain is connected to this inductor coil, so it will make switching and it will make a resonant circuit. So we will take the rectified output here at this capacitor. This is negative and connected to source, and drain is connected to this winding. So it will make a surge between ground and the positive line, that is positive line here. Diode is connected here and it is connected to this MOSFET. MOSFET will connect to this ground, so it will build a magnetic field. So that collapsing magnetic field will switch through the diode here and it will rectify, and we will receive this voltage from this diode. As the other power supplies, ATX power supplies, if we discuss a simple power supply, that is ATX. In ATX power supply, what is the difference? Here we take voltage, and here we have two capacitors here, and we have two switching components, MOSFETs or transistors are here to drive this power transformer. And here we have standby power supply set. It will make 5 volt and 12 volt. The same is here, just only difference between a simple power supply, simple ATX, and this active PFC ATX. It have an additional circuit, that is Pfc circuit. So when it will maintain voltage, in that case it will just only work as a flyback transformer. Why? Because to drive this transformer, it have just only one winding. It have no, this transformer does not have a center taped winding. Here it have just only one switching device, that is here. It will take the voltage, and it have a inductor load here, and then there is a current sensing. It will just only switch between ground and positive voltage. So it is using, I twisted this heatsink so to make a clear view for the components. I will use this magnifier application UC3845, and in Pfc Controller Circuit it is using 1CE PCS02 IC, and here it is using LM393 IC and 1CE PCS02. This active PFC controller, here it have LM393 IC, which will measure the voltage. It is for voltage measurement, and it will monitor how much voltage are output of this bridge rectifier. And then we have Pfc Controller Ic here. It will adjust the duty cycle to switch this choke to provide voltage, and it will switch this MOSFET, that is for PFC drive. And here we have rectifier for purging this capacitor, and here we have UC3845 IC, which is used to drive. Here it is using UC3845 IC to drive this transistor, this MOSFET, and this MOSFET will drive this transformer, and we will take output in the second side. We have 4 optocouplers here. Every optocoupler have separate function, And here we have standby power supply. Here it have a heatsink mounted. We have TNY268 PNIC that will drive this SMPS transfer, this standby transformer, SB transformer. So we will take regulated 5 volt output in the circuit, and we will take also 12 volt from the second winding. We have 2 windings for this transformer, and we have TL494, this IC. It is used to drive this fan, because it is not a 12 volt fan. It is to control its frequency depending on the temperature. Here we have LM339 IC. It will check all supplies, under voltage, over voltage, R conditions from these. All power supplies are reaching here, and every line is connected through a resistor, SMD resistor, and it have a different voltage levels. If any supply will go above or below the required limit, it will generate a turn off signal, which will accomplished through this optocoupler, these optocouplers. So these optocouplers are responsible for the first one here, that is for voltage regulation of these 5 volts. It is feedback from this. The second, third and fourth, these are involved in the under voltage, over voltage, and through this ATX supervisor DNA002, DNA1002D. So any power supply, 3.3 volts, 12 volts, 5 volts, if any power supply will go beyond its limit, it will generate a fail signal. So UC3845 IC will turn off immediately. Now if we check the circuit configuration, here we have LM393 IC, which will measure the DC voltage on the DC rail, and it will inform to this ICE1 PCS02 IC, that is Active PFC Controller, and it will adjust its switching time, duty cycle, to switch this MOSFET, power MOSFET, to drive this PFC choke. So this PFC inductor will maintain the voltage regulator here, rectifier here. It will rectify the voltage and it will pump to the capacitor here. Then we have, so here we have UC3845 IC. It will switch this 9N90 MOSFET. So it will work as a flyback switcher, as an offline switcher, because this time it is not using a center tape winding. It is using just only one winding in the primary. So it will switch and we will take output in the secondary side. It is using TNY268 IC that will switch this primary transformer, this standby transformer, and it will give output in the secondary, and we will take 12 volt and 5 volt that are for purple wire SB voltage, and 12 volt for switching. Now I just only connected the power, and we can monitor the first optocoupler. So it is 1.4 volt. So this optocoupler is working now. And if we check the other optocouplers, the second one, that is a reverse bias, minus 2.5 volt, minus 2.5 volt, 0 volt. So these three optocouplers are off. Now when we will power on, when we will turn on this power supply, now the first one here, this one is for standby voltage. The first optocoupler here, it will turn on for PFC voltage. Now it is giving 1.1 volt. First one, that is to turn on PFC. So Pfc circuit will active. The second for UC3845 IC, and the third one should remain off. It is reverse bias -9 volt. That is for fault protection. Over voltage, under voltage, this will turn off immediately. When it will enable, it is for protection. In case any power supply will go up or down, in that case this optocoupler will enabled. Now we have 3 optocouplers working. We can check again. 1.1 volt, it is working. It is reverse bias -8 volt. And the first one, that is 1 volt. So 3 optocouplers out of 4 are working. At this time, this TL494 it is working and switching this transformer. And here in the rectifier section, we have outputs. In the rectifier section, we have rectifiers for 12 volt, 5 volt, 3.3 volt, and we have these inductors, and we have output capacitors. This TL494, it is used to drive this fan depending on the temperature. How much is temperature, and this temperature sensor output, this temperature is collected in the rectifier here, and we have 2 output, 1 and 2. So it is collected here, this temperature sensor, it is collected here, and it will go to this IC TL494, and it will switch. So this TL494 will drive from this pin number 8, from this jumper to the connector, and pin number 9 to the connector. So it will give a drive signal to this fan. It is a 4-wire fan. It will adjust its speed, how much the temperature. It will set its switching frequency. Here we have LM339. It is to monitor the power on command, and it have to monitor all the power supplies here, and it have to give a feedback. This for over voltage protection and interlocking. And DNA1002, that IC will monitor all the outputs, and it will protect all outputs from under voltage, over voltage, over current, over temperature. So friends, I hope so this video is informative. If it is informative, give a thumb up. If you have any question, let me know in the comment box. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.